So these are your test questions, past questions. I will use them and then we'll see what we can get. So for your test, I said expect naming of compounds and also expect drawing of structures. So it's a two-way thing. They'll give you a compound and ask you to name it. They'll draw the structure, or they'll give you a name and ask you to draw the structure. Whichever way, let's use this for a start, please. Take down, please. Take down, please. For a start, please. Let's start with drawing structures. Here's a past question. Draw the structure of the following. Draw the structure of the following. Draw the structure of the following. All right, of the following, please. So we have this, please. Let's start with this, please. All right, so look up solution. If you're used to my classes, what I do is this. Before I solve, I will allow you to attempt it first, Abby, before I do it. But for time's sake, considering our scope, I won't do that one like that. So I'll just go straight. If you have a question, just answer. Ask, right? I won't give you time to start trying again because of time. I'll just be doing it. If the part you don't understand, call my attention. Just raise your hand, I'll get to you. All right, first things first, we have to draw the structure: cyclobutanol, 3-chloro-1-nitrobenzene, 1-chloro-4-nitrobenzene. So here's the task, please. First things first, I have a cyclobutanol. The term there says cyclo. We've agreed that when we want a compound is cyclo. What does it mean there? It means it's what there? In a ring format. That's all. Cyclo means it's in a ring format. Next up, I'm seeing a butanol. When we say but, how many carbon there? 4 carbon. So this simply means get 4 carbon. The first one there, cyclobutanol, get 4 carbon, and it should be in a ring structure. This is cyclobut. This is cyclobut. The next task that I have what there, an anol or alkanol. For your alkanol, how do you identify alkanol? The OH group. Which should now be, where do I put OH here? That's the question. Put it anywhere. So if I choose to put OH here, it's correct. If it's here, it's correct. If it's here, it's correct. So put the OH anywhere, it's correct. So I'm coming here, I'm doing OH, I'm having all right, so that's all, please. This is cyclobutanol, that's all. Number 2, that's cyclobutanol. Number 2, I have 3-chloro-nitrobenzene. Please, you are pleased to draw any structure depends on noting which of them is the parent atom. In this case here, my parent there is what there? Benzene. It's benzene. So first things first, draw a benzene ring. For my benzene ring, I'm having this. So here is okay. It's not complete yet. I'm having here. So here's a benzene ring. We said this is called Kekule's structure. You can choose to put these two here and this one here. It's still correct. It's called the delocalized pi bonding. Right? You can take it at any position. So this is my benzene there. Next up, I'm having a look up, please. I'm having a nitrobenzene. 1 nitrobenzene, please. To put your nitro is usually NO2. And when you now say 1 nitro, it means that nitro should come here. So I'm having this as NO2. So I have 1 nitrobenzene. Finally, I also have what there? 3-chloro. So it means from here, count 3 and put chlorine. So it also depends on how you want to get your answer. You can choose to count from here. Here, this is 1, 2, 3, and put chlorine here. It's correct. You can choose to do 1, 2, 3, and put chlorine here. You're correct. So whether you put the chlorine at this position or this position, it's correct. But I'm choosing mine here. So this now becomes position 1, 2, 3. So it becomes 3 chloro, 1 nitro, benzene. That's all. Number three is not really the regular. It's not really the regular, but well, let's see how it goes. So they said 1 chloro, 4 nitrobenzene. That's quite weird. But then, okay. I think the name is actually is weird, right? I feel this naming is weird. How can the 4 be the nitro, right? But then, if I'm to take this description, it means chlorine is at position 1, nitrogen or NO2 is at what there? 4. But I still feel this is a weird name. A weird name. Usually, the substituent should take the bigger number, and this one should be closer. But fine, let's use this. So I'm having my benzene ring again. It's still okay for you to do this. I've said this before. So I explained this in our last class. How we did benzene. This is still a benzene. It's okay. You can use the circle there. It's okay. But then let's make it as formal as we can. And by that, I mean put this as this, and this. All right, so I have this. Next task. Let me get my 1 chloro. So if it's 1 chloro, that means chlorine should be at position 1. So 1, 2, 3, 4, NO2. So it becomes 1 chloro, 4 nitro, benzene. So that's all. So this is how you draw these structures, please. All right, let's move on. Any questions, please? All right, next up, please. Let me highlight some few things to note about isomerism or isomers, and let's proceed, please. So let's highlight isomerism a bit. Please note the following, please. Isomerism or isomers. Note the following, please. Number one, alkenes. Number one, alkenes are isomers of cycloalkanes. Please note this one first. That's the first thing to note. We've defined isomerism before now. We talk about the types, chain, functional, geometric, but leave that one now. Let me just highlight some few points. Number two, note that dienes are isomers of alkynes. That's number two. Number three, note that alkanols are isomers with ethers. All right, so I think if you know these three things, there is nothing to give you on isomers that you can. So just know these three things, please. I didn't mention this thing when we did isomerism in class, but now I'm giving you now. So know these things, please. All right, let's use this concept to answer another past question. Take that, please. Give the names. Let's try this question, please. Give the names and two structures for the following. Give the name and two structures for the following. Give the name and two structures for the following. All right, look up, please. So this question here is actually to test your idea about isomerism or isomers. First things first, I'm giving C3H4. My first task would be C3H4. Is it an alkane, alkene, alkyne, alkanol? Which of them? I'm having alkene, I'm having alkyne. Is it an alkene or an alkyne? Of course, check the formula. For alkyne, I have CnH2n minus 2. So when it's 3 here, it becomes C3 into H2 times 3, 6 minus 2, 4. So it's an alkyne. So if you say give 2 isomers, just simply what there, come here. That's it. That means I'll create an alkyne and what again there? A diene. That's simple. So first things first, my alkyne. Alright, so I'm creating an alkyne with C3H4. First things first, my C3 carbon there. 1, 2, 3. That's C3. To make this an alkyne, it means I have to put what there? Triple bond. So it becomes 1, 2, 3. Automatically, this is now an alkyne. Of course, balance this up. How do you balance it? 1 here. We said for this stuff to be balanced there, each of them must have 4 bonds. This one has 1, 2, 3. This makes it 4. This has 1, 2, 3. This makes it 4. Balance. This one has 1. So 2, 3, and 4. So check this. I'm having 1, 2, 3, C3, 1, 2, 3, 4, H4. Balanced. So I've gotten my first structure. They said provide the name and the structure. I've gotten my first structure. That's 1 there. Let's get the name. What's the name of this compound there? Huh? Propine. Propine. Please, is it propine or 1 propine? Propine or 1 propine? If you are here in a previous class, I said propine and what there? 1 propine are the same thing. Why? Because there can be no 2 propine. If this man is here, I'm counting 1 before this, so it's a 1 propine. If I choose to move the triple bond here, I'll still have to count from here. So whether here or here, it's 1 propine. So it becomes what there? Propine, the same thing. I've gotten my propine, my alkyne. My next step should just be form a diene. So the second one, I want to form a diene. What's a diene? If you're not here, we discussed diene. We said dienes are simply compounds that have what there? 2 double bonds. It's telling you a di and an ene. So 2 double bonds. So it means create the same 3 carbon compounds. 1, 2, 3. Make this a diene. How? Put 2 double bonds. Between these 2, I'll put my first double bond. Between these 2, I'll put my second double bond. Balance of the structure. This one is now 1, 2, 3, 4. Balanced. This one here is 1, 2, 3, and 4. Balanced. This one here is 1, 2, 3, and 4 is balanced. So if I count, I have 1, 2, 3, C3, 1, 2, 3, 4, H4. That's correct. So name this compound. Of course, whether I choose to number from right to left or left to right, the same thing. So let's number it. I'm having 1, 2, 3. So how do we name dienes? For this one here, I'm having 1, 2, 3. 3 carbons is a what there? Prop. But we said for dienes, there's an A, Abby. You can remember. So this is not just prop. Okay, hold on. This is not just prop. If I want to get the position of the double bond, my first double bond from my numbering, my first double bond, if I'm counting like this, so I'll count carbon 1 before my first double bond, so it becomes 1. Moving on, if I go this way, I'll count carbon 2 before the double bond. So I'm having 1, 2. Now note, for dienes, you don't say prop 1, 2 diene. What do you say there? Propa 1, 2 diene. Please go check your notes. Discuss it. So for the dienes, there's always an A there. If it's but, it's not but 1, 2, no. It's buta 1, 2 diene. That's the idea. All right, I'm done with the first one. Let's come to this one here. C3H6. C3H6 is what there? An alkene, right? Yeah, alkene. Alkene general molecular formula is CnH2n. So when it's 3, becomes 2 times 3, 6. My tax number, they said create 2 structures. For my alkene, look at it here. So I'm saying that alkenes are what there? Isomers of what there? Cycloalkane. So the first thing there, form an alkene. Secondly, form what there? The cycloalkane. So first things first, number 1, let me form an alkene. For this one, C3, I'm having 1, 2, 3. To make this an alkene, put what there? Double bond. So I'm having 1, 2. This qualifies this as a what? An alkene. Balance of the structure, I'll put 1 here. So this one is now 1, 2, 3, and 4. 1, 2, 3. This makes it 4. 1, 2, 3, and 4. 1, 2, 3. C3. 1, 2, 3, 4, 5, 6. H6. That's correct. So name this compound. How do you name this? Which compound is this? Propene. If you say prop 1 in, note that there's what there? No prop 2 in. So if you want to say 1 propene or prop 1 in, no problem. Or you can say propene. Because prop 1, 2, 3, 3 carbon, prop, and then double bond alkene. My second structure, we said propene and cycloalkane. So it's as easy as use 3 to form a cycloalkane. For the fact that it's a cyclo, it means to be what there? A ring structure. So I'll now arrange 3 carbon to give me ring structure like this. Of course, it's a cycloalkane. For an alkane, I expect a single bond to become single bonded, single bonded, single bonded. So I have this. All right, so here's now a cycloalkane. Balance it up. I'm having 1, 2. You can just put your arrows there or say H2. It's correct. So 1, 2, 3, 4. 1, 2, H2, 3, 4. 1, 2, H2, 3, 4. So it becomes 1, 2, 3, C3, 2, 4, 6, H6. This compound becomes cyclopropane. Please get this man done on your own, please. Very fast, please. Get this man done on your own, please. Very fast. Get the third one, copy down. Get the third one done on your own, please. Very fast. By the way, let's get this done, please. So here's an alkyne. Here's an alkyne. First things first. 4 carbon, 1, 2, 3, 4. Make this an alkyne. Please, you can choose to put your triple bond here or here. For this case, let me use here. So I'm having this and this and this. So this one becomes 1, 2, 3, 4. This is balanced. This one becomes 1, 2, 3, 4. This is balanced. This is 1. I can put H3 here. Still correct. 1. I can put H3 here. Is still correct. How do I name this? This is 1, 2, 3, 4. 4 is boot. So it becomes boot. The triple bond is attached to carbon 2. So boot 2 ion. If you want to, you can bring this one here so that it becomes boot 1 ion. They are both correct. All right, number 2, we said alkynes are isomers of what there? Dienes. All right, so let's get a diene equivalent. So first is 4 carbon, 1, 2, 3, 4. It's now at your own discretion to put your double bond. For a diene, it means I'm having 2 double bonds. Put your 2 double bonds anywhere. You can come here and choose 1, 2 as the first one. Also here, 1, 2 as the second one. It's correct. You can choose 1, 2 here and 1, 2 here. It's still correct. Any one. Complete this single bond here. So this is 1, 2, H2, 1, 2, 3, 4, 1, 2, 3, H, 1, 2, 3, H, 1, 2, H2. So 1, 2, 3, 4, C4, 2, 3, 4, 5, 6, H6. Name this compound 1, 2, 3, 4. 4 is boot. And I said for your double bond, what is it now? Buta, add an A. So instead of proper, instead of boot, it becomes what there? Buta. All right, buta. Do your numbering 1, 2, 3, 4. The double bond is at carbon 1 here and then carbon 3 here. So it becomes 1, 3. Buta 1, 3 diene. So I have this. So that's how you get this stuff here. Buta 1, 3 diene. Before we move on, please. Before we move on, I have tested these two. Let's see if we can test one with this. Let me give you one with this. Let's see if we can test one with this, please. C3H8O. Yeah. So use this to name. So please see the different one. I now use H7 and 8. For 7, it's most likely what you have most likely will be your alkanol and alkanol, or your aldehyde and ketone. For alcohols or alkanols, you have this. So please see if you can get two structures of this. Let's move on, please. So look up. Look up. Let me answer this and let's proceed. Let me answer this. Let's proceed, please. First things first, for this one here, they won't tell you it's an alkanol. You have to be able to identify it. And that's why the general molecular formula idea is important. If I know my general molecular formula, I know that for the alkanols, what I have is CnH2n plus 1. What again there? OH. So if I look at this, it becomes C3, H into 2 times 3, 6, plus 1, 7, plus this one here, 8, and then O. That's the idea. So this is an alkanol. I can get an alkanol from this. So if that's true, that means let me get a 3-carbon alkanol. So it becomes 1, 2, 3. For an alkanol, we say put what there? OH. Now listen carefully. Listen carefully. I said, when we did a previous example, I said there's nothing like what there? Like 1 propine and 1 propene. For the alkanol, there is something like 1 propanol. Please get the difference. Look at this very well. I'm having 3 carbon here. Let me explain something. I'm having 3 carbon here. Let's say I want to use double bond. If I put double bond here and this, for my numbering, we said number from this part. So I'll come to double bond first. So it becomes 1, 2, 3. So it becomes prop 1 in. Let's reverse it. If I reverse it, bring these 2 here. It becomes this way and then this. For my proper numbering, I'll have to number 1, 2, 3. So it still becomes 1, whichever way you number it. Now this is for an alkene and alkyne. For an alkanol, it's not so. What do I mean? For an alkanol, like this one here, if I now choose to put the OH at the extreme, this one here, OH, and I now do 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4. What I have here should be called not just propanol, but what there? Propan 1-ol. Why? Because if I change this one here and bring it here, please, it cannot be the same thing. Because at this point now, if I number becomes 1, 2, so a 2 exists. All right, so bring this one here. This now becomes a 1 propanol or a propan 1-ol. That's the first one there. Number 2, let's get an ether. What's an ether? Huh? What's an ether? We'll do ethers. I think we did ethers in our previous class now, right? Last week, right? We did ethers, all right? Yes, we did. If you learned last week, we did ethers. But don't worry, look up. If it's your first time, go to our first class, our very first class. I gave you a table, serial number, homologous series, general molecular formula, and functional group. Please check. You had ether there. I said for ether you had R-O-R. Abi? Check, you had this. So look up, please. What does it mean? Look up, please. It means if I want to form an ether here, so listen, this one can have 2 answers. If you choose to write 1 propanol, it's okay. If you choose to use 2 propanol, it's still okay. Let's get the ether. For the ether here, my task will be this. I'm having R-O-R. I think the most important part there is the O, or the oxygen at the center. So I'm having O at the center here, this and this. What this R means is just simply alkyl group. If I'm having 3 carbon, it means form 3 carbon alkyl group from both sides. That means I can have CH3, that's what there? Methyl. Abi? For ethyl, what's your formula there? C2H what there? Fine, you can have this. So this is methyl, this is ethyl. If I combine them having, look up please. If I combine I'm having C and C2. In total, C3, H3 and H5, H8, and then O. So it's correct. That means for this I can come here and say CH3, C2, H5. Please, you should know how to draw this in full, right? CH2, CH3. How do you name this compound? Now listen, I showed them how to name this last time. How do you name this? I'm having one carbon. One carbon is what there? One carbon is what? So it becomes met. This one becomes an oxy. This one is 2. 2 is what there? Et. You call it as an alkane. It becomes what there? Ethane. This is called methoxyethane. Now keep it pending. What if you choose to flip it? If I flip it, that means this one comes first. So I'm having, now listen. Listen. I said better still if you want. See, if I flip it, it should be something like this: C2H5O and then CH3. I flipped it. But this stuff here is not proper. Not proper. So arrange it. If I have C2H5, please arrange it. This is a molecular formula. Arrange it in condensed form. What will it be there? CH3, Abi, CH2, what again there? O, what again here? CH3. So I have this. So C2H5. How do you name this? Please observe. It was met. 2 carbon gives you what there? Et. So it becomes ethoxy, what there? Ethoxy what? Methane. Please, methane because it's 1 carbon, ethoxymethane. So the idea is simple. Et, oxy, then methane. So if they say name 2, you can just pick this and this, or this and this. Now, hold on, no. Since they say draw the structure, don't give it like this. Give it like this instead. This one becomes C1, 2, 3, CH2, C1, 2, oxygen, O, C1, 2, 3. So here is what you should have, please. So the difference between a methoxyethane and an ethoxymethane. All right. Yes, question. Yes. Is that also an alkyl group for your level? Yes. On the next class, we'll do other things too. Alkyls are what there? Substituents from what there? Alkanes by what? The loss of 1 hydrogen. Next week, we'll look at a second type called the phenyls or the benzyl. What's a benzyl? A benzyl is a substituent that you get from a benzene by what there? Loss of 1 hydrogen. Example, phenyl. We'll treat in the next class. But for now, just hang on with this. All right, for recording purposes, please. Check your question, please. Compounds. Let's try this question, please. Compounds A, B, and C all have the molecular formula C5H10, full stop. A and B decolorizes bromine water, but C does not, full stop. B exists as 2 stereoisomers, but A does not show stereoisomerism, full stop. Use this information to deduce a possible structure for each of the compounds A, B, and C, and explain your deduction, full stop. State the meaning of the term stereoisomerism and explain how they arise in compound B. All right, so let's get this done, please. Let's get this done. Look up. Let's get this done, please. All right, so let's start with what we know and see how we can get an answer. First things first, I have 3 compounds here, A, B, and C. Next up, they say they have what there? Molecular formula of what? C5H10. All right, so let's see this done. I'm having a C5H10. So that's my first task. Okay, so what next? They said an A and B decolorize its bromine. Now, hold on. I have, when you did your practical, when you did that bromine something, which of the homologous series decolorizes bromine? Was it just alkene? It was alkene and what there? Alkyne that decolorizes bromine. So if they say A and B decolorizes, that means most likely A and B are what there? Either alkene and alkene, or alkyne and alkyne, or alkene and alkyne. But whichever way, my first deduction or my first hypothesis or my first inference is that A and B are most likely alkene, alkyne. Keep it pending. Let's move on. They said, but C does not. Which of them does not? So C is an alkane. So see, I'm doing it that. So A and B is most likely alkene, alkyne. C is an alkane. Proceeding, they said, B exists as what there? two stereoisomers. Let me break it down to the simplest form. When we say stereoisomers, what we mean in the basic sense is your cis and trans system. Cis and trans. Now, if you remember how we do cis and trans, it's something that looks like this. Cis and trans looks like this, something of this nature. Abi? Yes, this is cis and trans system. Now, let's still get something right. Let's still get something right, please. Considering this formula, C5H10, please, can this be an alkyne? Huh? No. This cannot be an alkyne. This can be what there? An alkene. For an alkene, what's the isomer? Cycloalkane. You now see where A falls under. Cycloalkane. Remember we said A was an alkane. And we know that the isomer of an alkene is what there? Cycloalkane. So we've gotten A. But keep it pending for now. So, listen again. Initially, we said A and B should be what there? Either alkene or what there? Alkyne. We've just said alkyne is not possible. Abi? Yes, because of what there? The formula. So if that's what it means, what does it mean there? It means that what there? A and B are both what there? Alkanes. Or alkenes. Double bond, please. It means A and B are both what there? Alkenes, because they decolorize what there? Bromine. So what kind of alkene? It has now specified that B, is it B? Yes, it says B exhibits what there? Stereoisomerism. But see what there? But A does not show. So here's the thing. It means that B is an alkene that exhibits stereoisomerism, while A is still an alkene, but it does not do what there? Exhibits stereoisomerism. A and B are both alkenes. B is showing cis trans. A is not showing cis trans. If A is not showing cis trans, what does it mean there? It's what? A straight carbon. All right, let's proceed there. All right, you said use the information. Okay, so let's get this done, please. So first things first, we know that A and B are what there? They are both alkenes. That's what we know. While C is what there? An alkane. Why an alkane? It doesn't decolorize bromine water. So which alkene will have C5H10? The cycle of it. We just said that. So let's get a cycloalkane with 5. That would be, so A is, therefore, I'm having 1, 2, 3, 4, 5. So I'm having 1, 2, 3, 4, 5. That's a cyclo. Let's mix an alkane. CH2, 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 C12H2, C12H2. So here's an alkane that has 1, 2, 3, 4, 5. C5, 2, 4, 6, 8, 10. H10. So therefore, is what? Cyclo what? Okay, it's A. It's C. Sorry. Right. So let me repeat this. Sorry. Yes. It said C is the alkane, please. So C is therefore a cycloalkane. That's 1, 2, 3, 4, 5. So here, 1, 2, H2, 4, 1, 2, H2, 4, 1, 2, H2, 4, 1, 2, H2, 4, 1, 2, H2, 4. So I have this. This now becomes a what there? Cyclo 1, 2, 3, 4, 5. 10, 3. I have deduced C. I'm left with what there? A and B. Let's get A. For A, what will A be? A is an alkene. Now we said we know what is an alkene, but it said A does not do what there? It doesn't do what there? Exhibit stereoisomerism. So we are having an alkene that is not cis and trans. If it is not cis and trans, what does it mean there? is a straight alkene. So I'm having C5, so it becomes 1, 2, 3, 4, 5. Make this an alkene, double bond. So I'm having this. 1, 2, H2, 4, 1, 2, 3, H, 1, 2, H, H, 1, 2, H, H, 1, 2, 3, and 4. So how do you name this? This is what? 1, I mean? 1, 2, 3, 4, 5. 5 is what? Prop. Pent, please, pent. Pent, 1 in, or 1 pentene. B is also an alkene that exhibits stereoisomerism. So because what there? Cis trans concept. So let's get B. Let's get B. So B is an alkene that is a stereoisomer. That means form a cis and a trans from this. So for my cis trans, my first case is to get these 2 carbons first and then complete it. C5, so you can come and you can say C, of course. C, I'm having 1, 2, 3, 4, one more C here, 5. So 1, 2, 3, 4, 5. Complete this. This becomes 1, 2, 3, and 4. 1, 2, 3, and 4. 1, 2, 3, and 4. 1, 2, 3, 4. 1, 2, 3, 4. Sorry. For this one here, excuse me, please. For this one here, we know how this should look like. Abi? Yes. For a cis trans, I'm having this. What I have on the board, please. Okay, let me make this H bigger. Having this. Please, what I have on the board, please. Is it a cis or a trans? Obviously cis. We said for cis, the 2 hydrogen will be what there on the same plane like this. So it gives you cis. So cis what? This is cis. Cis what? How do you number? Which of them gives you the shortest distance to double bond is from left. So I'm having 1, 2, 3, 4, 5. All right, so name this become cis pent, 5 carbon. Pent what there? Double bond is on carbon 2. Cis pent 2 what there? In. So I have this. If you want to use this trans, it's still correct. If you want to use the trans, it's still correct. That's what they say, deduce a possible. What's possible here? Cis is possible here. Trans is also what there? Possible here. So if your neighbor is doing trans and you're using cis, both of you are what there? Correct. That's it. I have the mark scheme. I have one of these mark scheme there. For the mark scheme, they'll give a question. They'll give list of possible answer. So while you're doing a cis, the next one is doing what there? A trans. Both of you are what there? Correct. So that's how we get this done. That's how we get this done. Last thing there says, states the meaning of stereoisomerism. All right, copy down. Let me give you a definition of stereoisomerism, and then we can proceed, please. So the next thing there says, what is stereoisomerism? Please, the definition, please. Stereoisomerism or spatial isomerism is a form of isomerism in which molecules have the same molecular formula and sequence of bonded atoms but differ in the 3-dimensional orientations of their atoms in space. Last thing there says, and explain how they arise in compound B. And explain how they arise in compound B. What would you say? Huh? Rigidity. How? And explain how they arise in compound B. What would you say? So you can just say, give them a simple man's concept. We said, we now say for stereoisomers, there are basically two types, which are what and what there, cis and trans. And hence, B becomes a cis structure. So that's how it arises in B. Now, since B is a stereoisomer, then it is either a cis or a trans structure. So hence, you have cis. That's just like a very simple way of putting your answer. All right, so that's that for that. Let's proceed. All right, so here's another class question here. This one says, give the names of the geometric isomers below. Give the names of the geometric isomers below. So you have this and this. Let's name this. How do you name this first? First things first, do your numbering. Now listen, use your eyes. See that if I choose a number from here or from here, it's the same thing. Abby? So that means this one here is not a deciding factor. I'll now switch over to my substituent. Observe that the substituents are both what there? Fluorine and fluorine. What does it mean? Start from anywhere. In other words, if this man was a bromine, now I would have to start from this part here. Why? From alphabetical order is B before F. That's by the way. So from here I'm having fluorine. Let's name this please. I said number from anywhere. If I count this way, it becomes, please, in total, how many carbon there? 1, 2, 3, 4, 5, 6. 6 is what there? Hex. Number 2, look at this. I have a double bond. So it becomes what there? An alkene. Number 3, here's a geometric isomers. This structure here, is it a cis or a trans? It's a cis because these two are on the same plane like this. So it's a cis. So it becomes cis. Cis. Next up, let's do numbering, please. 1, 2, 3, 4, 5, 6. It means the two fluorine are on carbon what there? 3 and 4. So what's the name of this compound there? No. Substituent first. 3, 4. Yes, that's so. So 3, 4 difluoro 6, not 6-hexane. 6-hex what there? Hex 3 in. Please careful. Careful, please. 3, 4 2 difluoro. So it's always the substituent before parents now. So okay, so assuming you had mentioned 6, where will now put fluoro? So imagine that you now saying 6 fluoro. 6 fluoro. No. So I'm having this, please. All right, so 6 hex. You also have to show the carbon bearing double bond. It's carbon 3 that bears double bond. So 6, 3 in. All right. This one here, let's get this done. First things first. What do I consider here first? What will be my focus? Is it the substituent or double bond? Huh? Listen. In this one here, the reason why I started from any side was because two of them gives you what there? The same numbering. I will number 1, 2, 3 before double bond. From here I'll have 1, 2, 3 before double bond. That's why I had to switch my focus to what there? Substituent. But somehow, substituent was still the same thing. So I did my stuff. In this case, your focus is always the double bond first. If I move from, of course I'm going this way here. This stuff here, is it a cis or a trans? So the first thing there is trans. That's the first thing. Number 2, how many carbon in total? 1, 2, 3, 4, 5, 6. That gives you what there? Hex. Number 3, functional group. Your functional group is a double bond. That becomes what there? Alkene. So how do you number this? Observe that if I move from here this way and from here this way, they are not the same thing. So the question is this: which direction gives you shortest possible distance to double bond? Is it from left to right or from right to left? It's from left to right. From left to right I have 1, 2. Carbon 2 bears double bond. From right I have 1, 2, 3 and then 4. So between 2 and 4, the simplest one there is what? 2. So 1, 2, 3, 4, 5, 6. All right. With that one done, first things first, pick out your substituents. My substituents are what there? Chlorine and what there? Iodine. We said for cases like this, we consider what there? Alphabetical order. Between chlorine and iodine, which one comes first? Chlorine. Chlorine is attached to what number there? So it becomes what there? 3 chloro, 2 iodo, what's saying 6. Trans what there? Hex. Trans hex 2 in. So that's it. I'm trying to name as many as I can and not skip some stuff. So I'm having this. Let's look at something about hybridization. Now listen. We've done this month before in a previous class. We discussed 3 types, Abi? SP, SP squared, SP cubed. SP is for which of them? SP is for which of them? Alkyne, Abi, alkane. SP is for alkyne. SP squared is for what there? Alkene. SP cubed is for what there? Apart from these 3, there are still other ones I want to show you today. But before then, so we know those 3. Let me show you about 2 new ones today. There's an S, there's a P, which you've not done, but I've seen the past question before, so let me bring it up now. But before then, so I'm not going to define what this means. You already have definition. Let me jump straight to the question on this. Take that, please. Sample problem. Indicate the type of hybrid orbitals. Please go and refer back to your notes on hybridization. Right? I'm not going through that. Let me just focus on what I've not done before. Indicate the type of hybrid orbitals used by carbon indicate the type of hybrid orbital, that is hybridization, used by carbon in the molecule and state the geometry of the bonding. So you have your examples here. These things are popular exam questions. These ones here. So please careful. All right. You're done. Look up. You're done. When they say state the geometry, what do they mean? State the shape. By geometry, they mean shape. Right? Let's get this done. For the first one, they said state the hybridization pattern. If I were you, my advice would be try to draw the structure. When you draw the structure, to give you a pictorial view of what you want to do. For this one, C2 or CH2 becomes CH2 double bonded to O. All right. First things first. What is the hybridization pattern? Is it SP, SP squared, SP cubed, SP whatever? What do you have there? So I'm having a double bond. It becomes what there? SP squared hybridized. What is the geometry? For geometry, here's how you get the geometry, please. If it's 3-sided, it's called a trigonal. That's all. By 3-sided, I mean, that's why I said draw it in full. If I draw this in full, I can now see this. Look at this now. I'm having here, straight line, here. So observe the 3 pattern. This is called a trigonal. Somehow, geometry is a trigonal structure. That's how you get the geometry. So draw it out, you'll see what it looks like. Let's get this one done. So first things first, draw the structure C, 3 hydrogen, 1, 2, 3, and then chlorine. I have Cl. Let's get hybridization. For hybridization, this is what you have here. Sp cube. Please, not Me3. Cube. What's the geometry? If I look at this, this is now 1, 2, this. Looks like a cross. All right. So it's 4. 4 is called tetrahedral. Called tetrahedral slash a tetragonal. So tetra 4, tetragonal. For this one, I don't have to start drawing structure again. Now listen, for this one, they were kind enough to give us CO2 because usually they'll give you the molecular formula as what there, CO2. It's now left for you to be able to draw the structure. But then again, they are nice enough to give us structure. So for a case like this, what is the hybridization pattern? Huh? Please, listen, listen. Normally it's a double bond, and for double bond, we expect an sp squared hybridization. But when the double bond is now double, as in the case of a diene, becomes what there? An sp. So please take note, please. When it's now double, it becomes no longer sp squared, but sp hybridized. So please take note. That's like the small difference. Let's get out the geometry. Let's get out geometry. For this one, what do you think it will be? That's a linear structure. Trigonal, tetragonal. What will it be? See pattern now. See pattern. 3, trigonal. 4, tetragonal. 2, all linear because what there? Linear gonal. That becomes a diagonal. Or diagonal what there? Linear structure. Please, for the fourth one, get out the hybridization as well as the geometry, please. For the fourth one, get out hybridization pattern as well as geometry. As well as geometry. Please, fast. What do you have for the first one? Sp is triple bond. Sp. Geometry. Linear or what there? Please, it's not diagonal, it's diagonal, not diagonal. You're not dividing into 2. All right, so that's how we get this man done. So please, he was asking why this is sp. Please, we've mentioned before, we said when it comes to double bond, for double bond, the hybridization pattern is sp squared. For single bond, is sp cubed. For a double bond, is sp. For a triple bond, is sp. That's how it's done. Yes. So far, so good. I've given you 3 hybridization pattern, sp, sp squared, sp cubed. But apart from that one there's an S and there's a P. So now there's 5 now. S, sp squared, sp squared, sp cubed, and then P. Take down, please. Aside the 3 major hybridization pattern, in bracket, sp, sp squared and sp cubed, close the bracket. Aside the 3 major hybridization pattern, that's sp squared, sp cubed, comma. There exist two other hybridization patterns. There exists two other hybridization pattern in bracket S and P. S and P. Full stop. In order of electronegativity, in order of electronegativity, these hybridization patterns, in order of electronegativity, these hybridization patterns are arranged thus. So please copy this down, please. So I'm trying to say this in your year one. Don't bother about trying to know what exactly S and P are. No, just know this thing. This is like this is how they always ask this. They say arrange the following in order of electronegativity. So we're having this. Maybe increasing electronegativity. You have this. All right, so that's like the new thing there. So now I'm telling you there are 5. By the time I get to year 2, now here they're no longer 5, they're now 7. So perhaps you now have P over 2. And then, I'm kidding, no? I'm kidding. The idea is just keep an open mind. You keep learning and learning and learning. All right, next concept, please. Electrophiles and nucleophiles. All right, definition. I said electrophiles are electron deficient species and can accept an electron pair from electron rich species. Full stop. They usually have a positive sign in bracket plus. They usually have a positive sign in bracket plus. Plus. Example. Example, you have this. So, electrophiles, electron deficient plus. So, etc. While nucleophiles, while nucleophiles are electron-rich species. Nucleophiles are electron-rich species and they donate electron pairs. Electron pairs, P-A-I-R-S, pairs, to electron deficient species. Example, this etc. In your test, what you should focus on is how do you define electrophile, how do you define nucleophile. Or they'll give you a subject to say species which are electron deficient are called dash. The answer is what there? Electrophile. So now say while electron rich species are called what there? Dash. That becomes what there? Nucleophiles. That's one pattern. An alternative pattern is that to list out a number of ions Then for number of ions, you say classify the following as what there? Electrophiles or what there? Nucleophiles. It's very simple. If it's plus, it's what there? Electrophiles. If it's negative, it's what there? Nucleophile. Number 3, if it is a Lewis structure, if it's Lewis, what do I mean? It has what there? Dots. So if it's Lewis, it becomes what there? Nucleophile. So that's about what you'll be asked there. So just note it, right? Positive, electrophiles, negative, nucleophiles, dots, nucleophiles. That's it. All right, let's move on. Have you been taught bond cleavage in class? Yes. Homolytic and heterolytic? Yes. All right, let's look at bond cleavage, please. Definition, bond cleavage, it is the breaking of bond between organic compounds. Full stop, that's all. So bond cleavage means breaking of bonds between organic compounds. That's all. Subheading, please. Types of bond cleavage. Types of bond cleavage. The first one is called heterolytic bond cleavage or heterolysis. Heterolytic bond cleavage or heterolysis. It is the breaking of a single bond. It is the breaking of a single bond with 2 electrons in the bond distributed. It is the breaking of a single bond with the 2 electrons in the bond distributed unevenly. With the 2 electrons in the bond distributed unevenly. Unevenly or unequally, whichever way. Unevenly or unequally between the two bonded atoms. Between the 2 bonded atoms. Or you can say between the atoms bound by the bond. Example, you have this. Sorry? No. Free radicals. So listen, please. Listen. One way to easily spot heterolysis is that after the breakup, in quotes, I mean chemistry breakup now. Do I break up? So after the breakup there, look at the products. If they are the same, it's a homolysis. If they're not the same, as you can see here, is heterolysis. Note that what you get after a bond cleavage is called your free radicals. Yes, they are ions, but the name there is free radicals. That's also a past question. To tell you, dash are got by bond cleavage. What you have there is free radicals. They are ions though, yes, but the chemical name there is free radicals. Free radicals. They are free men. All right, number 2. That's the first. Number 2, homolytic. Homolytic bond cleavage. Or homolysis. Or homolysis. Definition, please. It is a breaking of a single bond. It is a breaking of a single bond with the 2 electrons in the bond, distributed equally or evenly. With the 2 electrons in the bond distributed equally or evenly between the 2 atoms bound by the bond. Bound by the bond. Example. Example, you have this. So I've said the easiest way to know that it's a homolysis is that look at the product. If they are the same, simple, homolysis. If they are different, simple, heterolysis. It's that simple, please. So I said the easiest way to know is this. I said look at the products. If the products are the same, it's a homolysis. Homo, same. If the products are different, it's called what there? Heterolysis. That's all. So for homolysis, bond cleavage so that it's shared equally or evenly between the free radicals. Heterolysis, bond cleavage so that it's shared unequally. I think that's like the key word there. Equally, unequally, free radicals, whatever. So here's a sample. Here's a sample test question. Practice example, or here's a test question, please. Identify the type of process. Identify the type of process that has taken place. Identify the type of process that has taken place in each of the following covalent bond. In each of the following covalent bond. So you have this. You have this. You have A and B. They say identify the kind of process that's happened this. So the first thing you're seeing here is that this has broken down to A and B. This has broken down to C and D. Which of them is homolysis? Which of them is heterolysis? A is what there? Homolysis. B is what there? Heterolysis. So in a case like this, where you're not having alphabet there, your key task is not by looking if they are the same. They can't be the same. A and B cannot be the same. Well, except in mass. In mass, you now say we are A equal to B. Have it? And that's mass. But this is not chemistry. So what you now look at is for this. The same thing there. Homolysis, different, heterolysis. Please, this is a past question. Also know this one here. All right. Let's look at we've done this one. Let's now look at the next concept, please. Somebody is saying, how is it different? How is it different? I said, look at the product. This product and this product are not the same thing. Methyl and chlorine, heterolysis. Don't stress. Look at this one here. The products are the same. How? CH3, CH2, CH2, CH3. They're the same thing. That becomes homolysis. That's how it's done. So just look at the products. Are the products the same? Yes. Homolysis. Are they different? Yes. Heterolysis. In a case of alphabet, I've said there's no way that A and B can look the same. How do you want to bend it? At that point now, it's no longer if it looks the same now. It's more of if the dots like dots, that's like the key stuff there. Dot, the same thing. So homolysis. Plus, minus, different thing. Heterolysis. That's it. Any question again? Please give me that structure again, please. How do I name CH3 into what there? CH3 twice CH3. I've said as much as you can to easily name compound. First of all, draw the structure. Start with this one here, CH3. So it becomes C, 1, 2, 3. Next up, CH 2 times. So it becomes CH and then CH. H. Next up, CH3 twice. What will it come under? Obviously here, CH3. Here again, CH3. Finally to CH3, that becomes C. 1, 2, 3. Here's your compound. So it becomes, of course, numbering from left and right, the same thing. 1, 2, 3, 4. Becomes 2, 3. 2, 3, what again there? Dimethyl what there? Butane. Please open your eyes. These things, they exist. They exist. All right, so let's see the same case in a skeletal form. Let's look at this. All right. Please forgive my inconsistency in my triangle. This one looks bigger, but you get the concept. How do you name this compound? Huh? Longest continuous carbon chain, how many? So we know that at every vertex is a carbon. So 1, 2, 3, 4, 5, 6, 7, 8. That's what there. An oct. Better still, let me make it a none. Again, let me make it a deck. Aha. So I'm having 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. All right. So how do you name this first? Obviously, the numbering that will give me the shortest distance to double bond will be like this. I'm having 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 is a deck. So it becomes what there? Deck is 4 before double bond. Deck 4 and 6. 6 ion or descent. Is it descent or decant? Descent. Okay. Oh. So that's this. Is that okay? Let me give one example. Let me give one more example. Let me include something else here. Please, you have the next 3 minutes, please. See if you can provide the name of this compound, please. You have the next 3 minutes. See if you can provide the name of this compound, please. All right, so look up. I want to name this. What do I do? Very simple. Longest continuous carbon chain. We've stressed that thing too much. So I'm going straight. It has to be from here to here. Abby? Yes. Or from here to here. The same thing, is it not? Yes. Yeah. So I'm having 1, 2, 3, 4, 5, here, 6, 7, 8. It's an oct compound. It has now observe that this one here is not part of the parent carbon. So it becomes what there? Methyl. This is methyl. This one too is not part. So it becomes what there? Methyl. This one is not part. It becomes what there? Ethyl. 1, 2. Ethyl. So first things first, get inorganic. Inorganic is the bromo or bromine. So it becomes what there? 6 bromo, bromine at position 6. Then go to organic. I said for organic, it depends on the author. Some author will say take position before alphabet. So we'll say take alphabet before, but let's take alphabet. If I take alphabet, I'll have E before M. Ethyl, carbon what there? So it becomes what there? 5-ethyl. Come to methyl. Methyl occurs twice. Abi? Where and where? So it becomes what there? 2,3-dimethyl. Dimethyl, I'm done with substituents now. Now take the compound as a whole. That's oct. Oct what there? 2 and next up 4. Alright. Very simple. Or you can say at this point now say dimethyl 2-octane 4. Alright. Same thing. Same thing. Now listen. Look up, please. Let's get this in there. Look up, please. So here's what I told you earlier. I said for a compound of this nature here, I said I am naming or I am numbering from the position that gives me what there? Double bond first before triple. Now, what if it's in a case like this, right? We can still do that pattern, or alternatively, if you look at what they are saying, right? There's a pattern that they said, I think it just came to my mind now. Here's an alternative way. Look at this, please. Let me do a numbering here. If I number this, I'm doing both upper and lower numbering, please. So I'm doing upper numbering 1, 2, 3, 4, 5, 6, 7, 8, 9. Lower numbering 1, 2, 3, 4, 5, 6, 7, 8, 9. So please watch this, please. There's another concept of naming this. Let me use the one that the lecturers have been using. So here's the pattern here. So for a case like this, where they said this one is in quote terminal, that means close to the end. So if I want to number this, what do I do? So the other concept of naming this here would be if I go with upper numbering. From upper numbering, my two numbers would be upper numbering. Observe that double bond occurs at carbon 4, and then I want again there 8. So from upper numbering, I have 4 and 8. If I go with lower numbering, from lower numbering, it becomes from like I'm having what there 1 and what again there 1 and 5 before double bond 1 and 5. So we'll do a summation. If I sum this to gives you what there 12, sum this to gives you what there 6. And now I'm saying you now take the one that gives you the lowest sum, which is 6. Because these two here, if I sum 1 and 5, gives you 6. So I'll now take the one that gives me the lowest sum in quote. And that's which of them? Lower number, Nabi. So I'll now take off the upper numbering. So what will this now be there? Okay. That becomes what there? 9 is what? None. So none what there? 5 and 1. So that's another concept. Hold on. So that's another concept of doing this. All right. So listen. If a lecturer said you should use this one, no problem. So you can use this one still. That's the pattern. Yes, Chief. Let's hear you. Next concept. Let's look at carbonium ion. Definition: we said a carbonium ion is an organic cation in which the positive charge is located on a carbon atom. Full stop. Take down, please. Types. Number one, primary carbonium ion. Number one, primary carbonium ion. Take down, please. Here, the carbon which carries the positive charge. Here, the carbon which carries the positive charge is attached to only one alkyl group, is attached to only one alkyl group, to only one alkyl group, or just hydrogen, or just hydrogen, or just hydrogen. So please look up, please. So I'll do the first ones. Subsequently, you should be able to name it on your own, please. So the first one there, carbon bearing the plus sign. This now becomes, look up, please. Attach this to one alkyl group becomes, look at this, please. It becomes this. The least alkyl group I can have is CH3. So attach CH3 here. So this man has 1, 2. H2 makes it 4. This is a primary carbonium ion. Why? The carbon bearing the plus sign, let me bring it here, is attached to just one alkyl group, and then this. So see, look at my balancing. See here, 1, 2, 3, 4. And we said all just hydrogen. If it is just hydrogen, it will be carbonium ion having the plus sign. This is 1. I think it was there, CH3. So see how this balances. I'll tell you how this affects naming of compound much more later. But please note this. This is called a primary carbonium ion because this carbon is having just hydrogen, or perhaps is attached to just one alkyl group. So that's your example. Just keep it pending. I'll show you more things there. Let's do secondary carbonium ion. Here, the carbon which carries the positive charge, here, the carbon which carries the positive charge is attached to two alkyl group. Is attached to two alkyl group. Is attached to two alkyl group. So I'll do this one on my, I'll show you how this one is done. And then you go do, you define tertiary and give out the example. So look up, please. Look up. How is this done? Very simple. They'll give you a list of carbonium ion. Classify the following as primary, secondary, or tertiary. For this one, it's simple. So first things first, carbon bearing the plus sign, we said is attached to two alkyl group. The simplest of the alkyl group is CH3 methyl, but perhaps we're using methyl too much. So let's now add something else. Let's say propyl C3H7. This one here becomes a secondary carbonium ion because this one is attached to two alkyl groups, methyl by the left and propyl by the right. Observe that this one is not balanced yet. I'm having 1, 2, 3. One more H. That makes it 4. So this one here is a secondary carbonium ion. Please define tertiary on your own and give an example, please. Define tertiary on your own and give an example, please. So the third one there has to be tertiary carbonium ion. For a tertiary carbonium ion, the carbon bearing what there? The plus sign is attached to what there? 3 alkyl groups. So it's as simple as this. Becomes C there, having the plus sign. Please, the plus sign can still be here. Oh. Still okay. I now have my first alkyl group, CH3. My second alkyl group, C2H5. My third alkyl group, C4H9. Becomes a tertiary carbonium ion. becomes a tertiary carbonium ion. Let's see why we need this example. Let's use it to do a past question. So this is what you should be having, something like this. Or even if you brought this one up here and this man here, still okay. Even if you use methyl, it's still okay. Okay. All right. Let's note something. Let's note something. Note the hydrogen of the note. Is it break time? The hydrogen of the primary, secondary, and tertiary carbonium ion. The hydrogens or hydrogen. So we use hydrogen or hydrogens. That's hydrogen in bracket S. The hydrogen or hydrogens of the primary, secondary, and tertiary carbonium ion are referred to as primary, secondary, and tertiary hydrogens, respectively. Are referred to as primary, secondary, and tertiary hydrogens, respectively. Written as so please, if you see this, when you see 1 naught or 1 to power 0, this means primary. If you see this with a C, it means what there? Primary carbon. So what this means is primary. 2 naught like that means secondary. So whether it's hydrogen or C, this means primary hydrogen, secondary hydrogen, tertiary hydrogen. That's this. Full stop. Let's take an example, please. All right. Sample problem, please. Given the molecule below, all right. Given the molecule below, given the molecule below, you have this. So this molecule here. How many primary, secondary, and tertiary carbon atoms? How many primary, secondary, and tertiary carbon atoms are present in the molecule? How many primary, secondary, and tertiary carbon atoms are present in the molecule? Also find out the number of primary, secondary, and tertiary hydrogen present. Also find out the number of primary, secondary, and tertiary hydrogen present. Present. All right, so look up. When it comes to doing this, your best bet would be try to draw out the complete structure. So first things first, I'm having 1, 2, 3, 4, 5. So 1, 1, 2, 3, 4, 5. Observe that this is carbon 1, 2. Carbon 2, I have this one here. What's this? So carbon 2, I'm adding CH3 as a methyl. To complete this structure, I have H, 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 1, 2, 1, 2, 3, 4. All right, so I have a complete structure here. Okay, so I have this now. We asked to identify for each of them, identify each of the carbon here as a primary, a secondary, and a tertiary. My first task will now be label each of them. So let me call here A, B, C, D, E, and F. So I'm labeling this A, B, C, D, E, and F. So carbon A, primary or secondary, B, primary or secondary, C, primary or secondary, D, E, F. What do we have? So it's simple. First things first, let's get which of them are primary carbons. What's the idea of primary carbons? Primary carbons are simply carbons that have what there? One alkyl group attached to them. If I look at this, look at carbon A. Carbon A is attached to just this one here, this alkyl group. Please observe. Carbon A here is attached to just this alkyl group. So carbon A becomes a primary carbon. Hold on. Also observe carbon B. Carbon B have 1, 2, 3 hydrogen and then these attachments. Please. Look at carbon B. This carbon here has just 1, 2, 3 hydrogen and then all of this. So carbon B is a primary carbon. Hold on still. What about carbon C or carbon F? Observe that carbon F is just 1, 2, 3 and then all of this attached to this carbon here. F is also a primary carbon. In quotes, primary carbons are always carbons at the extreme. Don't forget that. Primary carbons are always carbons at the extreme. At the extreme will always be a primary carbon. All right, let's try secondary. Secondary carbons. For secondary carbons, which do we look at? Now listen, the idea about secondary is that what happens there now? Two alkyl group with what there attached to it. Which of them here has two alkyl group attached to it? Look at E. E has this one as an attachment and also this one as an attachment. So E is what there? Secondary. Look at D. D has all of this as an attachment on one side. D also has all of this as an attachment. So therefore, carbon D and E are both what there? Secondary carbons. Finally, let's look at tertiary. Hold on. For tertiary, what happens to it there? Look at C. C has one attachment. C has two attachments. C has what in there? Three attachments. So because what there? A tertiary carbon. That's it. So carbon C is tertiary. Do we get this or should I give you a note? I'll give you a note. Do you get this? Yes. So it's simple. Look up. Let's take them one by one again. Look up. Let's take one by one again. Look up. Listen, look up one by one. So classify the following as primary, secondary, or tertiary. It's simple. Look at how many alkyl in the attachment is alkyl attachment, not hydrogen. Start with A. Here's carbon A here. This man here has only one attachment. This one coming down. These ones are both hydrogen. So because of their primary A, that's all. Come to B. B has just one attachment. These ones are hydrogen. They don't count. So it's just one attachment. B is primary. Come to C. C has three attachments aside the hydrogen. So aside hydrogen here, C has 1, 2, and 3. So it becomes a tertiary carbon. That's simple. Come to D. D, aside the hydrogen, has only 2 attachments. This one and this one. That's secondary. Come to E. Aside the hydrogen, E has just 1 and 2 attachments. Is secondary. Come to F. F, aside the hydrogen, it has just 1 attachment. That's primary. It's as simple as that. No big deal. All right. And next task, they said we should find. So let's call this the A part. The B part said we should find the number of primary hydrogen. Primary hydrogen. We said the symbol is what there? 1 not H. How many? The primary hydrogen are simply the hydrogens of the primary carbons. My primary carbons include 1, 2, 3. So if I count, this one has how many there? 3. This one has how many there? 3. This one has how many there? So combine all of them becomes how many there? 9. So I'm having 9 primary this. So 1, 2, 3 for F, 3 for A, that's 6. 1, 2, 3, 9. That's it. Number 2, let's look at secondary carbon. Secondary hydrogen, please. Secondary hydrogen, that's this H. Please check how many, please. My secondary were just these 2. So it becomes the hydrogen of this 2 and then 3, 4. So I have 4 secondary hydrogen. Number 3, tertiary hydrogen. That becomes 3 not H. Please check how many tertiary do we have? So this carbon has what there? Just 1 hydrogen. This one here has just 1 hydrogen. That's how it's done. In a short format, from here, I can tell you how many they have. Your primary carbon will always have 3 hydrogen. In total, it will be 3 times the number of primary carbon. So 3 times, how many do I have here? 1, 2, 3. That gives you 9. So primary will always have 3 carbon. Note it. Secondary will always have 2 carbon. So it becomes 2 times the number of secondary atoms or secondary carbon. 2 times 2, that's 4. Tertiary will always have 1 hydrogen. It becomes 1 times the number of what? Tertiary carbon. 1 times 1, that's 1. That's it. So it's always number of primary carbons times 3, number of secondary carbons times 2, number of tertiary carbons times 3. That's how it's done. Times 1, please. Number of tertiary carbon times 1, please. Yeah. Let's take one more example on this and then we'll proceed. For this same example, let's try to get number of primary, secondary, tertiary, and their hydrogen. Now listen, trying to draw structure for a complex structure like this would be time wasting. What do I do? Figure it out. Number 1, primary are always at the extreme. What does it mean? This one here is a primary carbon. Yeah? At the extreme, primary carbon. 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 I have now named all the carbon here as being primary. Next up, this one here. Please check how many attachments does it have here? So it becomes what there? Secondary carbon. That's all. Don't forget at each junction. So this junction, this junction, this junction, please. This one has how many attachments? So it becomes what there? It's called a quaternary carbon. This one has how many attachments there? Becomes what there? Tertiary carbon. That's all. So I have 5 primary, 1 secondary, 1 tertiary, 1 quaternary carbon. Quaternary is spelled quaternary. Um, Quaternary. Quaternary carbon. No, I'm not drawing the place. Thank you. If you have something to draw, I say you don't have to draw. John, this stuff is complex. Trying to draw it out. It's so much of a headache. Just know, yes, Chief. How is this one here? How is it? It has four attachments now. One. Listen. At each junction is a carbon. So there's a carbon here, 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 and here. This one has 1, 2, 3, tertiary. Extremes are always primary, don't stress. This one has 1, 2, secondary. This one has 1, 2, 3, 4, quaternary. It's that simple. Yes. 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 Okay, let's draw this. This one becomes CH3, 1. I'm having CH3 here. Connect to this. That becomes what there? C this. Look at this, please. That's up and this. 1, 2. How many left there? 2. Abby? Come here. I have a carbon here. This one. This one has coming down. I have this one here. This carbon here. This is 1, 3, 4. From this center one like this center one like this, C 1 plus 3, 4. This one is now going up like this. So this one is now going up like this. The carbon somewhere here. This carbon has another attachment down. So it's coming down this way. This one is left alone. So 1 plus 3, 4. This one is going up. So I'm going up here. This is 1, 2, 3 plus 1, 4. Here has to be what there? Methyl. So I have this. So it's the same, this is structure here. So observe is the same concept. So let's do our maths. For primary, look up please. For primary hydrogen H. Please, we said it's equal to what there? Number of what? Number of primary carbon, Abi? How many there? 5 times what's the number there? 3. That should be equal to what there? 15 primary hydrogen. Now check it out. This is a primary. 3, 6, 9, 12, 15. It's correct. Let's look at secondary hydrogen. We said it's equal to number of secondary carbon. Please, how many secondary carbon do you have here? Just 1. 1 times. For this, what's the number there? 2. 1 times 2 gives you what there? 2. Okay, 2, let's put it this way, secondary hydrogen. And that's correct. This is my only secondary, this one here. That's this one. How many there? 2. It's correct. Let's do tertiary hydrogen. Please, how many tertiary hydrogen do you have there? 1. You multiply this one by how many? By 1. 1 times 1 gives you what there? 1 tertiary hydrogen. Where's the tertiary man? See him here, Abby. How many hydrogen here? 1. For quaternary, that's equal to how many quaternary carbon do you have there? 1 times, multiply this by what there? 0. That gives you what there? 0 quaternary hydrogen. So check out the quaternary carbon. There's no hydrogen on it. So that's it. Number of carbon times 3210. It's not that deep. All right. All right, let's look at types of reaction. I'll keep this within the scope of your text. There are 3 types of reactions. Number 1, addition reaction. That's number 1. Number 2, substitution reaction. Number 3, elimination reaction. Sorry? If you study rearrangement, no wahala. So if they call it rearrangement too, no problems. Um, so one of the questions you would see most likely is classify the following reactions as addition, substitution, and what there? Elimination. So how do you easily know which is addition, which is substitution, which is elimination? After addition, I said substitution, not subtraction. Somebody go and write subtraction exam. And it's not a joke. If you've ever marked student script before, student script is one of the funniest things you can mark. I tell you. Like you see things and you ask yourself, this one, is it, are you using your brain to write or what? No, I'm serious. Student script. That's why I'm not moved with this, what do you call it? I burn the paper. It doesn't move me. But I've seen things, so. Somebody I taught types of rocks. I taught some types of rocks. I had the person repeat it over and over and over again. The day before exam, the person repeated it over and over and over again. So I was happy that they would get types of rock. I gave them tests, types of rock. So what I write for me, number 1, Zuma rock. I'm not kidding, right? I'm not kidding. Now, types of rock, igneous, sedimentary, metamorphic. This guy repeated it in front of me how many times? Then exam, he now wrote for me, Zuma rock. The worst was that he wrote number 3, Aso rock. I'm not kidding. I was. Oh God. Oh God. Like Aso rock. You know. Oh God, Jesus help me. You know that point when you name types of rock, like you've discussed that you forgot that Aso rock is not actually a rock. There's actually a place. Aso rock. Someone will go and write substitution reaction. Trust me. And this same person will tell you, I burned the thing. I finished everything. 15 minutes still left. I submitted on time. All right. So, if I have addition, substitution, elimination, how can I easily identify? Take down, please. How to easily identify any? How to easily identify any, please? Please help me watch if this. I'm feeling that this space will soon get filled. So if just show space, space error, whatever, just let me know. Huh? All right. How to easily identify any? Number 1. How to easily identify any? Number 1. For addition reaction, comma, the complex hydrogen structure. For addition reaction, comma, the complex hydrocarbon, please. The complex hydrocarbon, please. For addition reaction, the complex hydrocarbon structure is broken down to a simpler hydrocarbon structure. So the complex hydrocarbon structure is broken down to a simpler hydrocarbon structure. Example, alkyne to alkene or alkene to alkane, of course. Example, alkyne, that's YNE, to alkene. So triple bond has broken down to what there? Double bond. Or from alkene to alkane. That's from double bond to single bond. So that's it. So that's how you identify addition. There will always be a breakdown of complex hydrocarbon to simpler one. Number two, substitution reaction. For substitution reaction, number 2, for substitution reaction, the hydrocarbon structure For substitution reaction, comma, the hydrocarbon structure in bracket sometimes complex. For substitution reaction, comma, the hydrocarbon structure in bracket sometimes complex remains the same. Please, for substitution, it remains the same. With some of the substituents, in bracket, hydrogen, comma, alkyl group, etc. With some of the substituents in bracket hydrogen, comma, alkyl group, etc. attached to it being replaced by, with some of the substituents attached to it being replaced by another substituent. Being replaced by another substituent. Full stop. Majorly for substitution reaction, comma, majorly for the substitution reaction, comma, the hydrogen structure retains its structure without being broken down. Majorly for substitution reaction, comma, the hydrogen structure retains its structure without being broken down or without being broken to a simpler hydrocarbon. Retains its structure without being broken down or broken to a simpler hydrocarbon, although some substituents may be added or removed. Although some substituents may be added or removed. Although some substituents may be added or removed. Finally, number three. For elimination reaction, one or more substituents are totally removed. For elimination reaction, one or more substituents are totally removed from a hydrocarbon. Totally removed from a hydrocarbon without replacement. For elimination reaction, one or more substituents are totally removed from a hydrocarbon without replacement. Without replacement. Full stop. This can cause the hydrocarbon to form another homologous series. This can cause the hydrocarbon to form another homologous series. All right, let's take some examples and then we'll go on break. Yes. PT. PDNI, platinum, palladium, nickel. I saw PPT there. I was like, well, whichever way. So look up, please. Expect these kind of stuff, if not in test, in exam. I've said for your test, focus more on how to name compounds and how to draw the structure if you're given the name. We've done that before now, but let's get this man up, please. So classify the following here as either addition, substitution, or elimination, or as we call it, rearrangement. Look up, please. How is it done? Listen, it's simple. For addition, the easiest way to spot an addition reaction is that a complex structure is broken down to a simpler one. Example, is there any one that involves alkene or alkyne breaking down to alkene or alkene breaking down to alkane? Anyone there? Yes. Which of them there? Number one, alkene is breaking down to what there? Alkane. This one, number one here, is an addition reaction. Number four, alkyne is breaking down to what there? Alkane. It's an addition reaction. That's number one. Number two, for substitution, check very well. For the two sides, I will have exactly the same structure. Just a change in perhaps an attachment. Please check. Is anyone that has the same structure on both sides? Yes. Which of them is that? Number two. Please observe. This is a benzene ring. This is a benzene ring. The only difference is that this is called, what name of this structure? No. The man's name now, what's it called? We did this now in previous class. This is called Kekule structure. We said benzene was discovered by a man called what there? August Kekule. Abi? That's another exam question, no? August Kekule. That's the name. Alright. Now listen. Listen. Observe that this and this are the same thing. The only difference is that for Kekule structure, here is supposed to be a hydrogen. The hydrogen here has been replaced by this one here. So this becomes what there? Substitution reaction. Where do I write that one there? Let me write it here. So what you have number two is substitution. Look at three critically. For number three, observe that the reactant is not breaking down. It's from alkane to alkene. It's not breaking down, number one. So it's not addition. Number two, it's not the same thing on both sides. Assuming it was just alkane, alkane, and maybe this one was changed. That I've said is what? Substitution. But then observe became what there? An alkene. So it's more like saying for an elimination, it's more like a build-up process. So if it is breaking down, it's most likely addition. If it is building up, it's what there? Most likely what there? Becomes this one's actually dehydration reaction. Dehydrohalogenation, please. Sorry. Halogen. Dehydrohalogenation. All right, so that's how this is done. Let's look at the concept, the one that involves shape, and we are done. Please. So our last task, please, before the test. Our last task, please, before our break. Our last task, please. So identify each of these as either addition, substitution, or elimination. For both cases, that's 1 and 2. Your easiest one to do is always substitution. Always your easiest. So if I were you, I won't stress much. I'll get substitution for each of them. For substitution, we say the compound itself does not change. Coming to the first one here, which one do I have a structure where it didn't really change? That's this one here. Observe. So observe that these two are the same thing there. The only thing that happened was that here was what? Substituted with this. So B becomes what there? Substitution. This substitution. Is that simple? That's for the first one. For the second one, which of them will do substitution? This was alkane to alkene, alkene to alkane. Observe C is alkane and alkane. Just like hydrogen here was replaced by what there? Chlorine. So this one becomes what? So that's always like the easiest one to get. The next one to get is addition. I think addition is easier. For addition, the complex one breaks down. So where do I have double bond to single or triple bond to double? Where do I have there? Observe C from double bond to single. It has broken down. That becomes what there? What we say for building up becomes what there? All right. Coming to this two, which of them there? From here to here, it is being broken down from an alkene to what there? An alkane. So it becomes what there? Addition. That becomes what there? All right. Most likely in your test or exam, you will see this way. Listen. You will see this stuff here. They'll now tell you A is equal to B is equal to C is equal to, for this one here, A is equal to elimination, B is equal to substitution, C equal to what there? Addition, please. Any questions? All right, let's take a break, please. Let's take a break. All right, let's take some past question, please. So this is from 2021. The question says, how many, that's this question 2 from 2021. 2A says, how many primary carbon does this stuff have? How many primary here? 2B says, how many secondary does it contain? 2C says, how many tertiary carbon does it contain? So please, on your own, please, very fast, please. Write out how many primary carbon you see here, how many secondary carbon you see here, and how many tertiary carbon you see here, please. Very fast, please. All right, so look up. Discover the number of primary, secondary, and tertiary carbons here. It all boils down to how well you know structures. First things first. I think these ones are easy to get. Let's try to see if we can get carbon here. We have C here. This will be CH what there? 2, Abby. So C here, C here, C here, C here, and C here. At every junction with a carbon. So let's start primary. Primary carbon, this carbon, how many do we have? Primary carbons are always at the extreme. By the extreme, it doesn't apply to cyclo. Please. My primary carbon will now be this one here. One of the easiest ways to spot a primary carbon is that a primary carbon is almost always attached to 3 hydrogen. Almost always attached to 3 hydrogen. If I look at this very well, I said it's at the extreme. My primary carbon here will be this one here. This one here. Of course, at the extreme. This one is attached to this one here. This one has just one attachment, which is all of this. So that's the first primary. The second primary will be this one here. This is a primary because this one is attached to all of this. More like I can detach this from here and I'll still have this one here. The third primary I have is this one here. Of course, this one is it has just one attachment to all of this. So I have three primary carbon. Let's get secondary carbon. For secondary carbon, look at those carbons that have 2 attachments. One of them will be this one here. This one has 2 attachments. This is, okay, let me call this, hold on, let me call this primary. Let me call this one here, primary. Let me call this one here, primary. This one has 2 attachments. This is secondary carbon. This one has 2 attachments, this and this. This is secondary carbon. This one has 2 attachments, this and this. This one here is what there? Secondary. This one has 2, 1, 2. This is secondary. This one has 3. 1, 2, 3. It's tertiary. Leave it there. So, okay, fine. Let's label them. Tertiary. This one has 1, 2, 3. That's tertiary. This one here has how many connections there? One and two. Ignoring the hydrogen. It's just one to this, one to this. This one becomes secondary. This one here has connection to which how many there? One and two. This one becomes secondary. This one has connection to how many there? Three. This one here one, this one here two, this one here three. Becomes tertiary. All right. So count the secondary. How many? One, two, three, four, five, six. All right. Six secondary carbons. All right. Finally, tertiary. Tertiary carbons. How many there? One, two, three. Three tertiary carbons. So that's the answer to this question, please. Any questions? All right. Next question. Same here. Last question. Which of the following compounds do not exist or are not possible? Which of the following compounds do not exist or are not possible? Or are not possible? All right. Which of these do not exist or is not possible or are not possible? Which of them? A cannot exist. Abi? Hold on. Can A exist? No. Why? How about that? Ethane. Ethane is just two carbon. So where are they getting 3 from? So ethane will not, this will not exist. 1,2 dichloroethane is possible, Abi? Cl. 1,2 dichloroethane. This is possible. What about 3? C. 5-ethyl. I'm having butyl. But how many there? 4 carbon. I'm having 1, 2, 3, 4. 4. This is butyl or butane. So where are you getting 5-ethyl from? How do you count 5 here? So note that this question has 2 answers. If you pick only one, it's half the mark. That's why I say chemistry, they are very clever. So actually open your eyes very well. I've seen this before. If you look at the marks, I think I've seen the marks for this one before. So they say the answer is A and C. If this is 5 marks and you pick only A, that's 2.5. So please open your eyes very well. So the answer is A and C. Both of them don't exist. All right. Let's proceed. Take down, please. Name the following compounds. Name the following compounds. All right. All right. So look up, please. Look up, please, very fast, please. Listen, please, before you go, look for way to get our notes. My notes, I've gone through the past questions, the so-called reactions, as solved example in my notes, right? I can't start going through all of them again. I'll just pick a handful of them that I think are important. Please go check them. Get notes from whoever has a note. Let's see how we can name this, please. I had to bring this one back, so I'll show you something. There's something peculiar about naming of the benzene and benzene derivative. We talked about benzene when we did in the last class. Was it last class? Or two classes ago? So we did benzene and, okay, we did the aromatics. And we said benzene and toluene are the proper aromatics. And we said there's something called benzene derivatives. We talked about something called toluene. Toluene is simply what there? Benzene with what there? A methyl. What you have is called a toluene. And in this class, I gave you toluene, I gave you styrene, I gave you again there, naphthalene. Abi? Yes. Yeah, so I gave you different structure. Please go check it out. So this one is called a toluene. When you have benzene with CH3, it's called toluene. When you have benzene with OH, it's called what there? Phenol. It's called a phenol. By the way, come back to this, please. Come back to this, please. Now, something peculiar about benzene that we mentioned was this. Always note the structure. For a benzene structure that has two substituents, it becomes what there? An OMP concept. We talk about OMP concept. OMP is called the auto meta. Auto, that's O. Meta, that's M. And then para, that's P. Listen and listen carefully. Auto, meta, and para is only used when I have two substituents. On your benzene ring, there are, here are your positions, please. So here's my benzene. Look up, please. Here's my benzene, please. Here is where your major substance is attached. Your auto has two positions. The auto positions are here and here. That's auto. Meta has two positions. The meta positions are here and here. Para has just one position, and that's here. So if I have a benzene structure such as this, where I have two, again I'm repeating, it only works for two substituents, like this one here, I can now bring in the OMP concept. How does it work? Usually, benzene usually have what's called two different names. Benzene can have two different names. The first name is when you consider the structure as a benzene. The second name is when you consider the structure as a benzene derivative. I'm calling this man a toluene because it's a benzene derivative. If I'm to consider this structure as a benzene, it means this one becomes the benzene. And hence, everything attached to this becomes automatically a substituent. So, as a benzene derivative, this is called a toluene. But as a benzene, this one becomes a substituent. I will do my positioning. It becomes 1. So, it becomes what there? 1 methyl. In case you're asked to provide two names, the first name will be calling this as a benzene derivative, toluene, or consider this man as benzene and call this a substituent, 1 methyl benzene. Same thing here. First things first, consider this structure as a benzene derivative. By benzene derivative, I mean benzene with this one here. When benzene has an OH, it's called what there? A phenol. So as a benzene derivative, this one becomes a phenol. That's concept 1. Concept 2, looking at this structure, I have just two substituents. And we said if you have two substituents, call it what there? OMP. Bring in OMP. Observe that chlorine is at this position here. That's what there? The M position. So hence, this becomes what there? M chlorophenol. That's all. Or, this is the best, here's your best shot. Or you can choose to use numbering. 1, 2, 3. So because what there? 3 chloro. Hold on. 1, 2, 3. Still considered as a benzene derivative, phenol. Please. What is most proper is the OMP concept. In fact, don't worry. Let me take up the numbering. But I'm saying this can still exist. But it's not the proper IUPAC name. But don't worry. Let's use OMP so I don't get you off track. All right. So M-chlorophenol. Know why? Or look up, please. Look up, please. Now listen. This name is benzene derivative. What if I consider this as a benzene? If I consider this as a benzene, it means that everything attached to it becomes a substituent. So these two are now substituents, no longer phenol, but now hydroxy. So I'm having 1, 2, 3. So because what there? Becomes 3 chloro, 1 hydroxy. Please, in the hydroxy, the L is not attached. Hydroxy benzene. So please observe, as a benzene derivative is phenol, as a benzene structure is OH and this. All right, get this one done, please. In this case, OMP concept will not apply. Again, I am stressing, OMP only apply for what there? 2 substituents. Is 3 substituents, OMP will not apply. So let's get this first as a benzene derivative, and then as what again there? As a benzene. As a benzene derivative, it means I'm calling both the benzene and whatever things attached to the top as one. So what will it be there? Call all of this. What will it be? If it's CH3, it's toluene. If it's OH, it's phenol. If it's NO2, this is what's it called there? Nitrobenzene. Since I can't use OMP here, what do I use there? Numbering. So I'm having 1, 2, 3. So it becomes 3 bromo, 2 hydroxy nitrobenzene. Or now call this as a benzene structure. Well, this is not a proper, it's not a proper benzene substituent, whatever. All right, call this as a benzene. As a benzene, I'm taking this one here. It means that every attachment is now considered a substituent. So because what there? 3 bromo, 2 hydroxy, 1 nitrobenzene. So that's like, so the idea is this: know when to use OMP and when not to. That's the idea. Know when to use OMP and when not to. That's the idea. Let me give you other examples. What do you have here? Huh? P dihydroxy. Am I having P dihydroxy? So here they're just testing your mind by turning it off, just flipping it. The same thing. That means if I flip this man properly, I should be having something of this nature. Perhaps here is OH, here is OH. Okay, this. So I have this. So if I flip it, I'll have this, the same thing. So how do you call this? Again, I have 2 substituents. OMP concept comes in. OMP. P hydroxy phenol becomes P hydroxy phenol. Consider this now as a benzene. They can actually provide 2 names. Consider this as a benzene. What will it be there? 1, 2, 3, 4. So because one there, 1, 4 dihydroxy benzene. All right. So please note this stuff there. Huh? Okay.